Welcome to The Explainer. Today, we're going to dive into a pretty radical shift in how we teach AI to reason. We're moving way beyond just getting it to imitate us and into something that feels a lot more like real problem solving. We're going to get into the engineering behind DeepSeek R1 and how it's being trained to think, well, more like a mathematician. All right, let's just kick things off with a huge question. When you give an AI a super complex problem and it spits out a perfect solution, is it actually reasoning its way through it? Or is it just being a brilliant parrot, perfectly mimicking patterns from the millions of examples it's seen? That distinction, well, it's everything.
And that whole parrot problem, it leads us straight into something we can call the imitation trap. This is really the fundamental challenge that even the most powerful AI models are up against right now.
Okay, so this gets right to the heart of it. The traditional way we train these models is by showing them a problem and then showing them a solution written by a human. The AI's only goal is to make its own answer look like that human example. It gets a reward for following the right steps, for looking smart, not necessarily for getting the right answer. So the engineers behind DeepSeek R1, they looked at this and decided to just flip the entire script. They came up with a new goal, a new mission statement for the AI that completely changes the game. And this slide lays out that crucial shift perfectly. The old way was all about matching the human process. But the new way, it's about optimizing for the outcome. The only thing that matters is getting the correct final answer. It doesn't matter how you get there. It's a huge change. It's the difference between a student just memorizing formulas and a real mathematician actually discovering something new. So how do you actually do that? Well, the main tool they're using is a really powerful technique called reinforcement learning, or RL. Instead of just showing the model the right answers, you let it try stuff on its own. It learns by pure trial and error, getting a simple reward when it does something right and, well, nothing when it gets it wrong. And here's what that setup looks like in practice. The state is just the math problem you give it. The action is the AI's entire solution from start to finish. And the reward is brutally simple. You get a 1 if the final answer is right and a 0 if it's wrong. That's it. There is absolutely no partial credit for showing your work. But wait a second. This creates a huge new problem, right? If you're only giving a thumbs up at the very end, how on earth does the model learn which of its reasoning paths are any good? The answer is this really clever, custom-built algorithm at the very core of the system. Let's just be really clear about the challenge here. You've got the AI making thousands, maybe millions of attempts at solving a problem. Some of them, by chance, will get the right answer, but most won't. How does the model figure out what the successful ones did right without a teacher there to guide every single step? The solution is just, it's so elegant. You don't need a human teacher or another AI to judge it. You just let the model's own answers compete against each other. It literally learns by comparing its own wins to its own losses. And this process is all powered by an algorithm they call GRPO. So here's how it works. First, the model generates a whole batch of different solutions to the same problem. Then, an automated system gives a reward to the ones that got the right answer. Now, step 3 is the real magic. The model doesn't just look at the winners. It calculates their advantage over the average of the entire group. That's how it figures out what makes a good solution truly better. And finally, it updates itself to think a little more like those winning strategies. Now, what's so cool about this GRPO method is how efficient it is. It gets rid of the need for a separate critic AI, which is a really common but super complicated part of other learning systems. It also uses some smart mathematical tricks, like clipping, which basically puts guardrails on the learning process. It stops the AI from making these wild, chaotic updates that could totally derail its training. Okay, so we have this incredible learning engine. But how do you actually use it to build a fully formed AI brain from the ground up? Well, let's take a look at the multi-stage training pipeline they came up with. This basically shows the entire assembly line. You start with a cold start in stage 1, just to give the model a basic grasp of language. Then, in stage 2, you unleash GRPO to force it to actually discover real problem-solving strategies. After that, stage 3 is about refinement, taking the very best solutions it came up with and polishing them so they're easy for a human to read. And finally, you merge all those skills together into one well-rounded model. So that's a massive amount of work and a totally different philosophy. what's the payoff? I mean, what actually happens when you teach an AI to optimize for the right answer instead of just copying what humans do? You get something absolutely incredible: emergent behaviors. These are complex skills that the model just develops on its own. Nobody programmed them in explicitly. It starts writing longer, more detailed explanations. It spontaneously starts double-checking its own work, finding and fixing its own mistakes. And maybe most amazing of all, it starts exploring new, creative ways to solve problems that weren't even in its original training data. It's like it's starting to actually think.
This quote really just says it all, doesn't it? This isn't just about a new algorithm. It's a completely different way of thinking about how you build intelligence. You're not trying to create a scribe that just copies what it has seen before. You're trying to create a genuine problem solver. And you're giving it one simple instruction: find the truth.
And that leaves us with one last massive question to think about. This approach was used for math and coding, right? But what happens when you apply this same philosophy, optimizing for the outcome, to scientific discovery, or to engineering, or medical research? What could we achieve with an AI partner that doesn't just repeat our knowledge back to us, but actually discovers its own?